7. Mathematics is essential in comprehending the universe. In the scientific methodology, mathematics plays an essential role in expressing the knowledge acquired through observation and experimentation. Particularly in physics, mathematics has central importance for comprehending the universe. When the existing phenomena are combined with mathematical laws, it becomes possible to make predictions about the future and retrodictions about the past. Because of mathematics' penetration into the universe, we can determine, for example, what happened in the first moments of the universe or the age of the Earth. Without mathematics, we could not manufacture or use technical wonders such as mobile phones, computers, and satellites. One simply cannot fully grasp essential theories of modern science, like quantum theory or the general theory of relativity, without mathematics. Even the most abstract mathematical theorems, from group theory to topology, from complex analysis to differential geometry, play significant roles in comprehending the universe. Two of the leading philosophers of the 20th century, Hilary Putnam and Willard Quine, argued for the indispensability of mathematics for science. According to this notion, known as Putnam-Quine indispensability thesis, mathematics is an indispensable aspect of the natural sciences. Thus, a science without mathematics is incomplete. This thesis is accepted widely by philosophers of science. Hartree Field, who argues that natural science without mathematics is possible, agrees that mathematics significantly facilitates and simplifies reasoning about nature. Mathematics, he thinks, is the most appropriate language for describing the universe and is, thus, indispensable to science. Though both widely assumed and taken for granted, the mathematization of the universe is both surprising and unexpected. In his famous article, The Unreasonable Effectiveness of Mathematics, Nobel laureate and one of the founders of quantum mechanics, Eugene Wigner, explained the astonishing accordance of mathematics with nature. The enormous usefulness of mathematics in the natural sciences is something bordering on the mysterious, and that there is no rational explanation for it. Nobel laureate physicist Steven Weinberg expresses a similar sentiment. It is very strange that mathematicians are led by their sense of mathematical beauty to develop formal structures that physicists only later find useful, even where the mathematician had no such goal in mind. Physicists generally find the ability of mathematicians to anticipate the mathematics needed in the theories of physics quite uncanny. It is as if Neil Armstrong in 1969, when he first set foot on the surface of the moon, had found in the lunar dust the footsteps of Jules Verne. The universe's yielding to mathematics is unexpected from the naturalist point of view. Naturalists generally take an anti-realist stance to the mathematical truth. They see the mathematical objects, numbers for example, as the outcomes of human mind. Mathematical realists, on the other hand, hold that mathematical objects exist independent of the human mind. If mathematical objects were merely products of the human mind, there would be no reason to expect that its structure would match the structure of the universe. Our thinking processes maybe, but not the universe. After all, the rules of chess don't describe the universe. Why then should another human construction, mathematics, describe the universe? Even if the naturalist held a realist perspective, they would still have no reason to expect mathematics to structure the universe. Because mathematical objects are abstract, they are not bound by space-time, and they do not have causal interactions. Thus, they cannot causally affect the universe in any way. If mathematical objects cannot causally affect the universe, then how is it possible that the universe is describable by mathematical objects? As a result, there is no reason for a naturalist, whether a realist or an anti-realist, to expect the universe to be describable through mathematics. Theism, on the other hand, can explain the mathematical structure of the universe under both realist and anti-realist standpoints. If mathematical objects exist transcendentally, as claimed by the realist, God could have created the universe in accordance with them. The causal gap between mathematical objects and the universe, in a naturalist perspective, disappears in theism. If mathematics is an invention of the human mind, there is still no problem in a theist perspective. Multiple views of realism are possible within theism. God might have created a world of mathematical objects independent from our universe, or mathematical objects could be the product of God's will, or they might somehow be related to aspects of God. As we have seen in the previous chapters, the fundamental expectation under the theist view is that the universe is to be understandable and of a compatible structure with the human mind. If the human mind is able to invent mathematics, and if mathematics is an efficient mediator for humans to reflect on nature more efficiently or make better predictions, then it is quite expectable for the universe to be created as mathematically understandable and compatible with the human mind. Since the universe is not a creation of human mind, naturalism has no explanation for a creation of human mind, or the mathematics to be in such compatibility with it. Theism has no difficulty here, as the universe is a creation of God. As a result, in theist perspective, the anti-realist position against mathematical objects does not cause any problem for the universe being in a mathematically describable structure. Anthony Flew, once one of the most famous atheists of the 20th century, counted the mathematical structure of the universe as one of the main reasons for his departure from atheism and conversion to belief in God. Many prominent figures of the scientific revolution, including Descartes, Kepler, Galileo, Leibniz, and Newton, believed that mathematics is the language in which God has written the universe. Scientists assume that mathematics is essential to comprehending the universe, although most don't explicitly think about the philosophical aspects we discuss here. However, many civilizations and thinkers throughout history fail to appreciate the role of mathematics in comprehending the universe. In the Quran, however, many verses affirm a relationship between mathematics and nature, such as, "The sun and the moon are perfectly calculated. He encompasses what is with them, and he has counted the numbers of all things." These verses support the presupposition that mathematics is essential for comprehending the universe. One of the primary meanings of the word qadar, which is used many times in the Quran, is to be bound by a measure. The following two verses are examples where the word qadar means measure. "Surely we have created everything according to a measure, and we send down from the sky water in measure." Verses marking mathematical measure support the importance of mathematics to science. In today's world, thanks to unprecedented practical utility of mathematics in producing new technologies and facilitating our lives, there is almost no scientist who does not assume that mathematics is essential in comprehending the universe.